Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going to be working on and trying to repair everyone's favorite 8-bit game console, or at least my favorite 8-bit game console, the Nintendo Entertainment System. On the bench today, I have two front-loader NESs. Both are broken as far as I'm aware, and then there's an original Famicom that was attempted to be AV modded by its previous owner, but I think that mod didn't go correctly, so I don't think the console is working right now. And lastly, we have a Japanese AV Famicom. I have no idea of the state of this unit. It might actually totally work. I haven't tested it though because I don't have the right cable to plug into the back. So in this video, I'd like to repair the two front loaders, re-AV mod the Famicom, and then test the AV Famicom to see if it's working. And if it is, then I just want to add some RCA jacks onto the back so I can just plug cables into it without having to use the special cable. So without further ado, let's get right to it. You know what's funny? I just recorded the intro and I'm laughing at myself because who am I kidding? There's no way I'm going to get to all four of these machines in one video. More than likely, the two front loaders are probably going to take up the lion's share of this video. I think what's going on with these is one of them has a buzz in the audio and the other one doesn't work at all. So I'm just going to move these two Japanese units off the bench, and most likely these will be in a part 2 or potentially beyond that, depending on what's wrong with these two front loaders. So for testing these two front loaders, I'm going to be using this multi-cart. It's one of these cheap clone ones, so if it gets shorted out, I don't really care. And for video capture, I'll be using the RetroTink 5X Pro. I have already rebooted it because it seems to always have problems when it's just sitting there turned on. So it's reset. Hopefully it'll work. It's designed to work with game consoles, so I'm sure it's not going to have any problems with these two Nintendos. One of the two front loaders actually has a door on, even though there's a piece missing and a cigarette burn on the front of the console. Looks like it got dropped as well. It's got a little bit of something in the corner. The other unit is really dirty. It has no door and it has a piece missing there. So we'll start with the one that actually has the door and we'll test that first. For powering up these NESs, you just need 9 volts AC. I'm going to be using this Atari 800 power supply. It outputs 9 volts AC. And it happens to have a connector that is fully compatible, at least with the front loader units. The RetroTink is set for composite video, which is obviously perfect for this. I'm gonna turn on my power supply and let's turn it on with nothing in the console, no cartridge. All right, power LED is blinking as it should. Ooh, that doesn't look correct though. When it's doing that flashing thing because of the lockout chip, we should just see a solid white screen or gray screen, and it had a whole bunch of lines in it. So in goes the cartridge. Let's see if that works. Okay, we're definitely having some kind of an issue here. Let's see if this thing can work. Could we just have a dodgy cartridge connector? The lines have gone away. Oh, there they are, they're back. That seems problematic right there. Just as a sanity check, just to make sure that my capture setup is working, I'm gonna grab another console. And I just wanna make sure that we have a fully operational system. Yes, we do. This one actually has an EverDrive in it. So it's interesting about this broken one. Oh, okay. So I guess we have a dodgy cartridge connector. That's probably why it wasn't powering up. But we're getting all these lines and interference, which is kind of curious. Do we have a bad crystal oscillator, or is the crystal oscillator running at the wrong frequency? Therefore, we actually are not getting the correct NTSC color carrier, which is why we have no color decoding. Let's see if we have an info screen or a status screen that can tell us a little info. So horizontal frequencies 15.74 kilohertz, 60.09 hertz. That's probably okay. I know the Nintendo is slightly different than standard NTSC. It's a little out of spec. Let's go back to this working console. 60.10 hertz and 15.75 kilohertz. Makes me kind of suspect that there's a crystal oscillator problem in this lower one, which is resulting in the vertical frequency to be slightly off, and the color carrier is going to be slightly off as well, which will cause no color video to be decoded. Back to the non-working one. I mean, the difference is so slight. So obviously, I think cartridge is probably not making a good connection. There it is. So let's just open this thing up and I'm going to take a look inside. I think there might be a little oscillator adjustment for adjusting the clock frequency, and maybe it's just off ever so slightly. I can just get this thing back on track and working properly. You know what? I have one of my spare boards. There's the crystal oscillator on an NTSC unit, 21.47727 megahertz. And this little oscillator adjuster here might be all we need to adjust to get this unit working again. Right, okay, I think I have all the screws loosened. There it is. Whoa, this thing's a little grimy on the inside. What's this all about? Okay, the fasteners are out, so off comes the shield. So with every single fastener out, you do have to slide the cartridge slot off. And then you can slide this off. This is the cartridge up-down thingy. And you just connect the reset power light power switch. You take off the two controller ports, and the lower RF shield comes off. Flipping the board over, this looks exactly like the one I just showed a second ago. And we have a Rev G PPU and a Rev G CPU. Now, the thing I find about Nintendo's is Ricoh makes the PPU and the CPU, and they're extremely reliable. I don't think I've ever had a Nintendo that actually had an IC that was failed. I'm pretty sure the other Nintendo front loader isn't quite working, but I think, well, I wouldn't be surprised if it's just a cartridge slot problem. These are the Achilles heel of these units. Now, typically, I've always found that you can get these Nintendos fully operational with just deoxit. Contact cleaner is all you really need to get these working again, unless there's any kind of visible corrosion on here, because like water intrusion into the console. Sometimes you can have corrosion on the edge connector because it's not gold coated. It's just, I guess it's like tinned with solder, essentially. So that can cause a little bit of an issue. But in the case of this particular console, the edge connector looks just fine. So for us to be able to run this with the game cartridge, we're going to need to get this sort of back together in a way that I can put the cartridge in, and it needs to sort of be parallel to the board like that. And we're going to need to operate this upside down, obviously, so I can make the adjustment to this while it's running. So we power this on. Okay. You can ignore the fact that it's all blown out. That is strictly a RetroTink problem right now. So I'm just going to use a little ceramic tool to try to adjust this. I think this little tool is doing the trick. It looks like we're gone down 60.09. Let's go the other way. Ah, okay. So no matter how I turn this, it is not working. So I'm just trying to get that 60.08 up to 16.10. And yep, that's not working. Okay, I grabbed the parts board. This is one that I know works because I have tick marks on here. Let's see if I can get this booted up with the janky cartridge connector. Okay, there we go. We have good color. Let's turn the little adjustment here on this and see if we can get it to look screwed up like it is on the other one. All right, so no. You can see the color starts to have issues, just slightly. In fact, there it is saying 60.09, and we still have color. But it looks like no matter how I adjust this one, we never have an issue. It goes to 60.09, but the color always stays locked in perfectly. So on the working console, I've connected up to the clock input on the PPU, just because it's easier since it's pin 18. And it's not like the frequency counter on here is perfect, but you know, 21.55, 37, it kind of drifts around a little bit. But we can turn this and see if this makes any difference at all that's visible. Not really. Doesn't feel like the frequency counter is accurate enough on here. Now the Rigol actually has a hardware frequency counter, and that's what's displayed right there, 21.4759 megahertz. And what we're actually looking for is 21.47727. So 21.47727, I think is what it actually is. The connection's not the best on here. Oh, look at that. Okay, so yeah, this adjustment does work, and we can dial it right in. 21.4771, 21.47727. This here is perfect and close enough. So I'm going to say that that is adjusted correctly on this unit, which is the working one. Let's try out the non-working one. I don't have a cartridge connected, but that is totally fine. And there's our frequency oscillator, 21.472. Now, it certainly doesn't seem like it's wildly off, but because it's divided down, I suppose that is. The other one I was able to dial right into 21.47. That's just a bad connection here. Looks like 21.43 is about as close as I can get it. And I guess that's just not close enough. It's obviously producing a video output. The picture's not rolling, it's stable and whatnot, and the CPU is running. So we're just ever so slightly off. So if we take a look at the schematics for the NES, there's that crystal oscillator at 21.47727 megahertz, and you see these little capacitors around it. And it's not entirely clear to me which of these is the adjustable capacitor, but it's my assumption that something has drifted on this console, which is causing us not to be able to dial in the exact frequency. I don't think it's the actual crystal that's the problem, because you could see that turning that little adjustment does change the frequency coming from the crystal. So I think it's going to be worth me firing up the system, measuring the clock signal, and taking some small little disc capacitors and touching them on the board to see which way they affect the clock signal, higher or lower. My assumption is it's not going to be this 51 or the 220 over here, because those are on the outputs of these two drivers. It's going to be one of these capacitors that are very close to the crystal oscillator that's going to make the difference, almost certainly the 30 or the 18. And hopefully you can see this. If I touch the back of the board on either of these two components, it actually slows down the oscillation slightly. Now it's only a slight change, but it does slow it down. So that's my feeling, that adding extra capacitance, because I'm pretty sure your finger adds capacitance, slows it down. So maybe I need to go lower on these values. So I think I'm just going to start by removing the 18 picofarad entirely. It's at 0.4730 megahertz right now. And you know what I'm going to do as well? There's some gunk on the back of this board here. I'm just going to clean this up. What if the gunk is actually causing this issue? Perhaps before I remove any component from the board, that is what I should do. Yeah, there's definitely some junk that's landed right here. So I'll just get a little toothbrush. I'll clean this up first. I did that cleaning, we're exactly the same, 21.4730 megahertz, so no change whatsoever. Maybe we're too far off now, we're far off the other way, 21.4825 megahertz. Let's try adjusting the little adjustment. Oh, 21.4779, that is really close. All right, so now the question is, will we have color? Oh yeah, we do indeed. We still have a ton of interference. That kind of screams that maybe we have a problem with the main reservoir cap that is on the voltage regulation part of the circuit, which happens to be this large cap. I probably should have addressed this issue first. I just thought those interference patterns were probably coming from the color carrier being off, but that's obviously not the case. And maybe the voltage regulation problems on here is upsetting the clock circuit, and that's what was causing it to be off. I'll switch back to this scope. It's just easier for me to film. I have it hooked onto the 5-volt regulator onto the pin that's the rightmost pin. Let's see what we get here. Do we have a whole bunch of ripple? So we're currently set for 400 millivolts per division, and you see that we definitely have this terrible looking ripple on here. Let's see if we can measure that. Yep, there it is, 1.27 megahertz. And this is right on the 5-volt rail coming out of the regulator. I don't necessarily think it's this cap, because we would be seeing 120 hertz ripple, for instance. This is very high frequency. Now what I can do is, there's the voltage regulator. I'm going to clip onto the input side, which is there. And let's turn this back on. And it's going to take this a moment to settle, but now we're going to be looking at the higher voltage that's going into here. Oh, wow. Yeah, that looks bad as well. All right, well, I think this pretty much tells us that this main filter cap is bad, I guess. We have a ripple of 6.5 volts going into that regulator. So it's trying its best to produce a nice smooth DC, but it just cannot. It absolutely cannot, not with that kind of ripple going into it. So let's open this up and get that cap off of there. That's probably the problem. I can smell the fishy electrolyte smell as I desolder that. So cotton bud, a little bit of cleaning. New capacitor is installed. Let's see what happens. Oh, we still have a ton of ripple. Wait a second, what's going on here? Is there something wrong with the diodes? Is there a shorted diode in here that's causing the AC to go directly through to the capacitor? If we take a look at the schematics for the power supply, the AC comes in, goes through a bridge rectifier. That's the capacitor that I just swapped out. It goes through the power switch, and then it makes its way to the 7805. We should be seeing 13 volts DC without any ripple. What is going on? I mean, I saw that ripple on the input side of the 7805. Only explanation for something like that is the bridge rectifier has a short, which would then feed the AC directly through. But then why was it that high frequency AC? This cap was definitely bad though. Let's test this. I got my tester right here. Yeah, so there's the original cap clipped on. It was like nanofarads, picofarads. And you see it's clipped on correctly. So this cap is basically dead. But the one I just installed on the board is a brand new Nichicon, so there's nothing wrong with this cap. So I've never really worked on one of these before, but there's the DC input jack. My assumption is these are the diodes. In fact, I'm pretty sure that is exactly the case because there's one leg of the capacitor. And this one here is the other connected to ground. So this is the positive lead of the cap. And these are the 4 diodes that make up the bridge rectifier. So let's just quickly test those for shorts. Okay, first diode, that looks good. How about this one? 0.6, that's good. This one here, 0.6. And the last one here, 0.58. That all looks perfect. I am super confused. What were we seeing on the oscilloscope there a second ago? All right, so I'm clipped on to the positive output of the bridge rectifier. That's the main lead of the cap. Just quickly test this out. Okay, with the AC hooked up, and it's actually off right now, but I guess that still actually runs the power into the cap. We have 14 volts, and if we turn it on, it drops down to 12.5. It still looks kind of ripply though. But I guess proof is in the pudding, so let's just exit out of the menu here, and I have the cartridge back in there. No, that still looks absolutely horrible. Okay, so my hypothesis is the bad capacitor actually damaged the voltage regulator. So let's get this out of the board. And I don't think there's really an easy way for me to test this, so it's easier just to swap this out with a different one. Luckily, these parts are absolutely dirt common and they're easy to find and very cheap. All right, here we go again. The console is off. That's why we're seeing 14 volts. As soon as we turn it on, it's going to load the transformer down. Oh, I don't know if that's any better or not. It's sort of bouncing around still. Okay, let's try again with the video connected. Oh, there we go. That was it. It's freaking fixed. So now we have no more interference. I'm really curious to see if the crystal oscillator is still running at the exact same frequency I left it at, or if that weird 5-volt rail was potentially having a negative effect on the oscillator, which is why removing this little tiny capacitor got us color back, at least before I fixed the 5-volt rail. Nope, it didn't change the oscillator output at all. It just looks a lot cleaner. It was a little noisy before. 21.4778 megahertz. And we're looking for, on the crystal, 21.47727. So it's slightly fast, but it's such a tiny difference, it doesn't matter. In fact, I just gave it a little tweak, and now we're at 21.4772 megahertz, which is perfect. That is exactly what it should be. All right, we're ready to put this thing back together. First thing I'm going to do, oops, that was too much. I just want to kind of scrub these contacts with a little deoxit. Just using a paper towel. You can use something like a magic eraser. That does a good job as well. I'm just trying to get a little bit of this oxide off the board. Yeah, so see a little bit's coming off there. It's also interesting. It looks like a little bit of rework was done on this expansion port connector right in that spot. That's flux that's right there. All right, before we slide this on, I'm just going to give it a little coating of deoxit on the bottom and the top. And I'm just going to put some deoxit right on the contacts on the little connector there. In fact, I'll just put some on the top edge of this cartridge as well, just so it kind of gets it in there. I mean, this thing was already working without issue. It's funny with the deoxit, it goes in and out so easily. But yeah, we were having no problems with this the whole time when it was running. Last thing I'm going to do is I'm just going to put a little deoxit right here on these pins. They can get a little oxidized. We'll just plug the controller in a few times. A little stronger deoxit can go a long way. And by stronger, I mean this stuff here. This can really help rejuvenate those pins. But I was just using the normal D5 stuff there, which generally does a perfect job. Okay, here we go. Is this gonna work? Oh yeah, it looks good. Let's try Bomberman 2. All right. Looks perfect. I mean, it's as good as the composite video looks on a regular NES. And the sound? No issues. Yes. Now, I picked this game because it's good to play through the laggy OBS, is how I'm playing it, through the capture device. But yeah, I mean, all looks normal. There's noise on the audio, typical. This game is so good. Oops. Yeah, there we go. Let's just try a different game. Bionic Commando, one of my favorites. There's a pretty good multi-cart, this 100 best whatever, because let's just turn the audio down so you don't have to hear that super loud. It just got a really good selection of games on it. Now, of course, this particular cartridge is running at 3.3 volts. It's using 5-volt tolerant flash and whatever mappers it has in there. So it's not ideal. And there's a whole lot of conjecture on if that can like damage your NES and stuff like that. I don't use this that often. This is really just my testing cart. But as you can see, it's, well, it's working perfectly. And that is what's important. This NES, well, it had two faults, obviously. We had a bad crystal oscillator for some reason. I mean, it wasn't the crystal oscillator itself that was bad. It was the associated timing circuit around it that was having an issue, which I have to say I've never run into before, but just removing that extra little cap. Oh yeah, this is a buggy version of the game. It's buggy, yes. I recall this problem now with this cart, actually. Oops. Yeah, well, anyways. Anyhow, as I was saying, the crystal oscillator on here had drifted lower, which resulted in no NTSC color because the color carrier was too far off for the decoder to work. So removing this 18 picofarad cap from the board allowed me to tune it up to the correct frequency using my Rigol scope. Then we figured out there was noise and interference on the picture, and it turned out this capacitor had gone bad. Now, it doesn't really look leaky, but I could smell the fishy smell when I desoldered it, even though it didn't really look like there was leakage on the board. For whatever reason, when we measured this with my tester, it basically measured nothing. Like it was just not there at all. So I think that excessive ripple had damaged the voltage regulator that was on there, the original Hitachi part. So I had to swap that out as well. So new cap and new regulator. And now this machine is working perfectly. A little bit of cleaning on the cartridge just to make sure that the game works when you put it in or out. I didn't even disable the locker or the lockout chip, but that doesn't seem to matter. Yep, this thing is just working, even though this clone cartridge is sometimes problematic with the locker chip, but generally if this works, then the real games are gonna work as well. All right, the cigarette burn NES is all fixed up. Next, let's move on to the one without the door that's all real grimy. Let's see what this one's doing. Okay, this one's all plugged in. I don't have a cartridge in there yet. Wow, it is dirty. If we turn it on, okay, we're getting a normal gray screen. This is acting as if, well, the lockout chip's unhappy because it's not detecting a cartridge. Let's pop in the multi-cart. Okay, it's just doing the same thing. Let's move it around a little bit. Slightly different. It's just a black screen now. Okay. Well, maybe we have a bad cartridge connector in there. I don't think anyone's been in here taking the screws out. I just went through a little nest or something, spider nest, I guess. Okay, what do we have inside? Oh, that's a dirty console. Yeah, this poor console has seen better days. Just keep that screw there. Oh, there's a bunch of pet hair in there. Kind of grimy in here. I wonder if something like contact cleaner was sprayed in there at some point. At least the board is looking okay. There's just a lot of pet hair on it. All right, so this board itself is looking really good. There's a little bit of spiderweb stuff on there. We have full-size SRAMs. The NES can accommodate both footprints. And anytime I've ever seen these, they always seem to have the skinny packages on them. Yeah, if we look here, there are two separate footprints. Just this row of pins is not used with these larger ICs. Rev G, so kind of same as the other one. There are some little quirks and features that are different from all the different revisions, but doesn't really affect, you know, overall usage. Everything here looks fine. Don't see anything out of the ordinary whatsoever, except for this grossness here, but it's not that big a deal. And looking at this, there's definitely a little bit of corrosion, although it's nothing bad. So maybe the cartridge connector is damaged. Let's see here. Does everything look okay? This looks fine. I'm just looking for pins that are out of place. That's odd right there. What's happening there? See how this is bent over? It's broken. So that might be our issue right there. Could be those pins are farther in though, but maybe they're out of alignment. So what I'm gonna do is, I guess, I'm gonna clean this board and then we'll fiddle with this and see if we can get it working. Okay, so a little deoxits on there on the upper and lower pins. And I'm totally suspecting this might work now. Ooh, nearly there. Press the reset button, didn't quite come to life. So yeah, we have a cartridge connector issue with this console, obviously. Yep, there we go, we're working. So there's nothing actually wrong with this console except for just dodgy contacts on the connector. So maybe with the deoxit, we're good. I'm just gonna put some deoxit on the cartridge or the controller connector as well. Okay, here we go. Just a solid gray screen. All right. Interesting. Interesting. It's not flashing, so the lockout circuit is happy. Yeah, but oddly enough, it's unhappy. There it is, working. But if I let go, will it stay working? All right, here's Bomberman. Seemingly working fine at the moment. Definitely still feels dodgy compared to the other one, which was rock solid from the start. So let's see if I bump this. Wow, it's still working. I'm surprised. I figured it would crash. Let's take it in and out. What, did I just fix it by moving it around a little bit? Ah, maybe not. The cartridge mechanism's not screwed in right now, so that could be part of it. Let me put some of these screws in. 4 screws are in. It's funny, is it actually working? Yeah, I mean, you can navigate, but obviously the graphics part of the cartridge aren't coming through properly. That's funny. What is this, Gradius? Gradius? I never knew how to say that. Yes, this is obviously what this is. Let's see if the music is working. Oh, it's not plugged in. That would be why you don't have sound. Okay, there it is. I think this is Gradius 2. So that's interesting. Yeah. So it works. How reliable is this? Not that reliable. Not as reliable as the other console. I mean, it seems to work more often than not though, right? Yeah, I mean, now it seems fine. Maybe it just needed that whole in and out thing with the deoxit. All right, banging it around, still working. Bubble bobble. Turn this audio down so it's not quite so loud. Start. Yeah, I mean, we're looking good now. It's not perfect. Probably needs a new cartridge connector just as the pins are a little bent up, just, you know, from age or whatever. But overall, oops. Let's put this in and out a couple more times. Yeah, that's okay. Yeah, looking good. I didn't try this in the other one, but we have the EverDrive, which should be working. It is. I didn't put the mod on here so we could hear the Japanese audio, so I can't run Castlevania 3. Well, I can. It just won't be any extra sound. But yep, here's Micro Mages looking good. I mean, as good as a composite NES video looks, which is a thing, you know, with the pixels and the dots. Kind of endearing, isn't it? No weird lines or anything or interference on this one, so there's no problems with the voltage regulation or the main cap. Kind of funny, this one's like been treated so badly, and yet everything looks good on here, right? So that's pretty funny. That the other one that was in much better physical shape doesn't have any issues with its capacitors like this one does. I gotta look around the camera here, whoop. This game is amazing, by the way. It's very, very fun. Highly recommend picking up a copy if you haven't already. Whoops. And look, it didn't work that time. It's not flashing, but it just didn't work. A little jiggle of the cartridge That's all it takes to make it work though. So it's working a whole lot better than it was initially before I took it apart. So I really feel the deoxit does absolute wonders for making these NESs work again. This machine was probably junk because even with some contact cleaner in there, because I could see some residue, still wasn't working. When, you know, now it seems to work pretty much every time. And if it doesn't work for some reason, you just jiggle the cartridge side to side and then it starts to work. And that's my trick, by the way. If you have an NES, don't blow on the cartridge and stuff. Just move it around a little bit, and that's all it usually takes. Let's see if we can get it to mess up again. It's really not going to mess up, is it? It's just going to work every single time. Let's see if I start one of the games and we move the cartridge while it's in here. Look, it's not even crashing. Amazing. Yeah, clearly it's working so much better than it was originally. You know, I had this game when I was a kid, Adventure Island, and it was infuriating. I really didn't like this game at all. Yeah, I don't know. I just, I don't know. The music, I think, just kind of got to me because it's not an easy game, or at least I didn't think it was easy. And then the music is just like, hey, you suck. That's kind of how I felt the music was, at least. I know there's like a cutesy music. It just repeats over and over again. Oh, there's a secret thing there. With the skateboard, you can't stop to pick that up. The music just repeats over and over again, and it's just, I don't know, it just really bothered me. I could still kind of play it. I don't remember how far I got with this back in the day when I was a kid, but I also know that I never really want to go back to playing it again. Nope. Okay, so one of the things about this NES is it's missing its door. Now what I did is I went and found an STL file to print, which is this right here. And I don't know if it's any good, but I figure a door is better than no door, at least keeping critters and stuff out. Now I know you can go online and buy a door dirt cheap, but you know, this is a grimy old NES, so I figured might as well just try the STL file. To get the new door in, you just have to take the screws out and get this little black plastic off. Now it looks like this isn't quite gonna work. I think that's because this little round part here is just a little bit too thick. It's got to fit inside of there, and the same thing is going to have to happen on this side with this round piece. So I'm going to have to get some sandpaper, or you know what, I'm going to use the Dremel to try to like Dremel that down a little bit. So the little holders and the screws are back in, and this is how the door works. I mean, it works, it stays up, it closes, it just doesn't really close all the way. I think a little bit more shaping could have fixed it, but to be honest, that's good enough. So this is funny. I put this back together and something was rattling around inside, and it's this, and it's like a piece of hard clear plastic that somehow made its way inside of the console. All right, there we have it. The NES is a little bit less gross to touch, but it's all back together. The door, probably after enough opening and closing, you know, might actually work, maybe. Let's see if this thing still works though, after I gave it a little bit of a clean and bumped it around a whole bunch. Oh yeah, that just works. Zelda 1. There we go. Nice. You know, does this have a battery? Yes, there's actually a battery in this cheap cartridge, now I think about it. Super Mario Bros. 3. Pretty sure this works fine. I don't think I played through the whole game or anything on this cheap cartridge, but I recall it seemed to be glitch-free pretty much, and I struggled to play Super Mario Brothers, any of them, through the capture device. It's very laggy, and it makes it very difficult to play just from muscle memory. But as you can see, the game is functional and working, which is the important part. I want to get it to kind of mess up again. Let's see. No. How about if we take it out? Put it in lackadaisically? Nah, this thing really just works now. And just in case anyone wants to see all the games that are on this particular cartridge, I'll just scroll through them here so you can take a look and slow it down. It's a decent set. All the Mega Mans are on here. I don't think this has any fake crap games on here either. It's all generally a good selection. I think that was it, 143 games. But the one thing I do remember about this cart, like I showed earlier, is that Bionic Commando does not work properly. Glitches out and is unplayable, unfortunately. And there may be other games on here that are like that, but this one for sure is one of those games. And with that, NES number 2, fully functional and working perfectly now, and not so gross to touch as well. All right, next up we're going to take a look at the Famicom, or the AV Famicom. I think it's called the AV Famicom specifically because this actually has an AV out, and the original Famicoms only had RF. Now in the intro I mentioned I didn't have the right cable to plug into this, and that's because this uses the same connector as the Super Nintendo. And you're probably shocked to find out that I only recently got a Super Nintendo and it was given to me by someone local, and I didn't have any cables with it, so I bought a cable for it, but I bought an RGB cable for it so I could output to one of my Commodore 1084 monitors. Clearly, this NES does not have RGB, this is composite only, so if I plug that same cable I have into here, I'm not going to get any video. Now you might look at this and think that this looks the same as the top loader NES, and it does. It's very similar, but it's not exactly the same. So unlike the original Famicom, this does use external controllers, but like the original Famicom, it has the 15-pin expansion port that was used to plug in additional accessories, like on the original Famicom, the keyboard, the light gun, extra controllers, things like that. So this is still there and does still work. And as far as I'm aware, the light gun or the zapper uses some extra pins on here that aren't wired up on this Famicom because they are intended to be used on the expansion port. So those signals are routed to this connector instead. So theoretically, if you plug the zapper into at least one of these ports, it's not going to work. I'm not 100% sure on that, but I did a little bit of reading and that's seemingly what I figured out. Now, since this is a Famicom, you cannot use an NES cartridge in there. It's a totally different connector and it doesn't fit. So I have this, the PowerJoy or the PJ008, and this is what we can use to do some testing with this console. Now on the bottom of this, we have HVC 101 and HVC 002. Don't know which this is, but this was sent in on a recent mail call episode. And I don't remember if this one is working or not. It was disassembled when I got it, and I just loosely reassembled it so that I wouldn't lose any of the parts. One thing Nintendo did do, at least with this version of the Famicom, is they reduced some of the ICs down to this single Nintendo branded chip. You still have the same static RAM that you found on all the other units, along with this latch, a 373. There were some additional logic ICs down here, along with, I think, some circuitry for switching the audio or mixing the audio between the cartridge input and the CPU, since the Famicom supports external audio. I think that's happening inside this chip. Now for testing this, since I don't have a way to connect up to the AV out, I think I'm just going to have to first connect up some wires directly to the pins. And if it does work, I will probably add some RCA jacks somewhere around right here. I will have to drill into the case, but I think that's going to be nice from a usability perspective, other than having to always worry about finding the right cable for this. But flipping the board over, we get a look at the AV connector. Looks like we have some voltage that goes to it. Looks like 5 volts. This would be the output of the regulator. That would be the input, because this thicker trace goes all the way down here to the power switch, which then comes back, connects to the capacitor. This is that smoothing cap that we replaced on the first unit. And then we have the bridge rectifier, and that takes the AC, converts that into DC. And yeah, so this is the output. The 5 volts goes down to the components and the cartridge connector, but yeah, it goes also to the AV jack. And it seems that there are only 2 signals connected to the AV jack, so if I'm going to do some kind of mods with an RCA connector, then I'll just have to tap directly into those signals. We'll start with the leftmost pin, at least with it flipped upside down. And let me hit the power switch. There's no cartridge in here, but that's fine. We should still get a video signal. Something blew up on here just now. Oh, you know what? It takes DC input, not AC input. Oh, I swear that this would have been a bridge rectifier right there, those 4 pins. But actually that looks like a coil. Oh dear, oh dear, oh dear. I just made the assumption that all the Nintendos used AC input. Doesn't say anything on the bottom label there, but it's pretty clear right there. It says DC in, and I completely missed that. Well, let's hope the 7805 that's on here took the brunt of the damage. I don't see anything looks out of the ordinary here. Luckily, I have spares of all of these chips except for the Nintendo one. So if anything bad happened here, I'd be able to fix that. But seems like whatever bad happened up there. So let me disassemble this so I can fix my mistake. All right, well, we can kind of see our problem. The 7805 is what took the brunt of that damage. I might have to switch out this cap as well since it was given AC volts directly. It wouldn't have been overvoltaged, but it certainly got AC on there, which wouldn't have been a good thing for it. I am sorry, the little Hitachi part. I absolutely damaged you by giving you 9 volts AC. Okay, for reinstalling the new part, I just have to attach it to the heatsink because I don't know how long the leads need to be. Okay, I have a new 1000 microfarad cap installed, and that's actually 50 volts versus the original, which was, I think, 25. The 7805 is installed, and now what I need to do, because it's not labeled anywhere on here, is figure out if this is center positive or center negative. I have a feeling, knowing Nintendo, that this is going to be center negative. So it's very easy to figure this out. Put your multimeter in continuity mode, touch the center pin, and then check the ground plane. And yes, this is absolutely center negative, which kind of sucks because I don't think I have anything with center negative. So I think I'm going to actually rewire this to be center positive. And I know this is going to be contentious because I hear the comments right now. The original is center negative. Don't change it. I'm going to change it. I'm going to put a label on here. This is for my own ease of use. Because here in the basement, I have center positive power supplies. I really don't keep center negative stuff. Anything that has center negative, I usually rewire, or to be honest, I replace the jack with USB Type-C power delivery anyways, which I've done on my Super Nintendo and my Sega Genesis, which I think are 2 consoles that probably were center negative, and I never had the original power supplies for either of those units. So the USB Type-C on both of those is much easier for me to run those than a power supply I don't have laying around. I have lots and lots of center positive power supplies, 9 volts, 5 volts, 12 volts, all the different ones. But what I don't have down here in the basement, I know I can just make one by cutting the cable and rewiring it, is center negative stuff. So I'd rather rewire the console, label it appropriately, so that it's easier to use in the future for me. So looking at the cap that I just reinstalled, this is the negative pin. We can look at which pin from the power supply jack is negative, and it's this one right here. The positive goes to this pin. Now it comes off the barrel jack, goes to this coil, where it just bridges across here, and then it makes its way to the cap. Now the easiest way to rewire this is to just cut these 2 traces, there and there, and just use some jumper links to wire them up appropriately to the capacitor. All right, so I've broken those 2 connections, but it actually looks like this pin, which is what's going to negative, actually it's connected on the other side as well. There's sort of a flood fill. So I will have to cut through this trace, but you notice these vias, that means this trace is actually on both sides of the board going to this pin. So I'm going to cut through it on this side and on the other side. Okay, it's kind of ugly, but it absolutely is going to work. And yep, this has been rewired, so the center is now positive. All right, just to double check, we actually have 9 volts DC. This is plugged into a USB-C power bank. And yep, there we go, 9 volts DC on the cap, so we're looking good. And out of the regulator, we're getting a nice solid 5 volts, so that looks great. I'm gonna say that's a video signal, and since there's no cartridge in there, we're not gonna get anything except for just like a blank screen, and that looks exactly what we have. So I just labeled the board A and V. And it actually makes sense that the audio is this one on the left because both of these pins on the far left side were connected together. I think that's because the cable that connects to the Super Nintendo is, or has right and left audio. So you have to bridge those together so that the mono sound of the NES outputs correctly. And then this pin, which goes to that little trace there, that's the video signal. Okay, the RetroTink is connected up to the video output. It's also clipped on the ground. Let's see what kind of video signal we get. We should just get solid gray screen. Okay, fair. So we should take this PowerJoy cartridge, stick this in. Let's see, what do we get? There we go, it's working. So our little excursion with AC through the voltage regulator didn't actually damage the console. Okay, so let's try a game here. Wow, there aren't really any jail bars on here because I know that the regular Famicom is Jail Bar City. Okay, I hooked up the audio, so let's see if we have sound for Goonies. Yeah, it sounds like we do. I really don't know how to play this game at all. Oh, that didn't do anything. Oh, hey, I saved one of the kids, okay. All right, the AV Famicom does appear to be working perfectly. None of the important components, which of course are these chips here, got damaged by getting AC volts sent into the unit. The 7805s are pretty good at protecting equipment when you do bad stuff to them, and that's exactly what happened in this case. So with the top cover on, I'm looking for space to put these jacks. Obviously there's room on the sides, but I'd rather it go on the back. So I think that in this area right there is the appropriate spot. There's plenty of space in there for these to go. And then we'll just run the cables over here to these points or those points. And we won't disable that connector. We'll leave that in place, but just give you the option of connecting to RCA jacks. Now, unfortunately, I do not have a yellow one. I only have red and black. So in the future, if I want to change out the black one for a yellow one for video, I can do that. But to be honest, it's totally fine the way it is. So that's where they're going to go. Time for some drilling. And there we go. Connections are made. The blue wire is the video and it is shielded. The red wire is the audio, and I do have the ground connections just looped or connected together with these two jacks. I added extra length because if you need to take these thing apart in the future, it is a permanent connection, so you can just desolder right here or on the bottom of the board. But so it's not annoying to just open this up if you have to do a repair. There's enough length here. Okay, let's pop in the old Power Joy. All right, here we go. Uh-oh. Okay, I think I just have a bad connection here with this cheap cartridge. Try that again. There we go. It's working. I really know or don't have any idea what I'm supposed to be doing with this game. Oh, I guess I have invincibility. Interesting. Okay, I'm playing City Connection now. Do I know what I'm doing here either? No, not even a little bit. And with that, the AV Famicom is all set. Rewired the input for the power so that I won't have a repeat of what I did before where I killed this 7805. And of course we have actual RCA jacks on there just for easier connection than using the Super Famicom / SNES AV cable that this thing uses. Was this also used on the Nintendo 64? It's possible, I never had one of those, so don't really know. Anyhow, this is a nifty little console, I think pretty rare here in North America at least, so I'm pretty glad to have this to complete out my original NES collection. And I suppose that means maybe we should take a look at the original Famicom. This thing is in absolute mint condition, basically just a little bit dirty, but no yellowing, which is fantastic. And I'm not even going to try to test this as it is, because this was fully disassembled when I got it, and it had some mods that were done on the main board. And I just roughly reassembled this simply so I could just keep it all together. Now, there are a couple different ways to AV mod your original Famicom, and a lot of the times people just replace the entire RF modulator power supply board, and the modern recreation will then just have a TRSS jack that replaces this RCA jack, and using a breakout cable that goes to a couple RCA jacks and just plug it into your TV. This one though has an RF modulator right there, and it only supports RF, and this board also has the bridge rectifier along with the 7805, so this creates the 5 volt that the rest of the computer or console uses. As you notice, there are some mods, and I think there's some more stuff on the top. So at the minimum, we need to undo whatever was done to this and just see if it's producing a normal video signal and working correctly, because I was told that this thing was not working right. And once we can confirm we have some graphics being displayed with the cartridge, then we can proceed to try to come up with a new mod to output the composite video and audio from this unit. With all the fasteners removed, we can lift the board out. And I think, yes, that's right. The power switch is permanently attached. You can remove it from the case, but it's kind of under the wire and stuff. So we'll just leave this off to the side, try to examine what kind of mods have been done to this. All right, so there's a transistor there. It looks like that was originally installed on the board and it was lifted. So if we just take this off and restore it back on the board, and then once I remove all these extra wires and there's a couple caps on the backside, I think this thing should work. It was a pretty typical mod I saw people talking about, that you go from pin 20 or 21 on the PPU, whatever the video out pin is, probably that one right there, so pin 20, and you go into this transistor that was originally used to buffer the video and send it over to the RF modulator through this ribbon cable, and you add some extra components, and then that is your new video buffer, which theoretically should work. It's a little less complicated than some of the other video output circuits on the other NESs, but theoretically this could do the trick. So let's just remove all of this stuff and restore a transistor back onto the board, and let's see if this thing works. Okay, so that's coming off. Let's see what's under here. Is there some damage? Looks pretty crusty under there. We gotta look at that a little more closely. Noticing some kind of component's been removed from the board in that spot. And this looks pretty bad over here. Let's just see what's kind of going on there. I'm gonna first clean it up a little bit. All right, over in this section, nothing looks bad. I'm just gonna reflow a few joints that looks dry and crusty. Oh, I see the problem here. There's no pin 21 on the PPU. I'm pretty sure the video output is pin 21, not pin 20, which is where this contraption was soldered onto. And that pin, it's just missing. The PPU is a Rev E, as is the CPU, so it's a bit older. I have spare PPUs, so I can pop a new one in. With the leg there missing, clearly, it's not gonna work. Obviously, I can just replace the transistor there. That'll restore that. But yeah, we gotta solve that problem. I removed all the little bits that were attached to the transistor. Let's see if the transistor is still working. Oh yes, it is. Cool, PNP. And pin 1 with the little notch, that is the emitter. I just cleaned off the legs on the transistor so I could try to put this back in the board. All right, the original transistor is back in the board exactly where it was when this thing was built. Now we just need to try to sort this issue out. All right, so I used the Dremel to kind of carve into the IC body a little bit, and we do see some copper, which I think is actually the output of this chip. So I've installed an offcut because I think it's going to be easier to bend that and touch that little piece of copper that I've exposed. I think it's connected, it doesn't seem to move. So all we can do is just power this up, see what happens. We should see a video output from that pin. Now, as for the Famicom, I actually don't know if this is AC input or DC. So I am going to double check first using the multimeter because I don't want a repeat of last time. Okay, yeah, we do have center negative and it's obviously DC. And just double checking, so the capacitor negative side, which has the stripe, is connected directly to the shield, which is negative as well, which is the center pin. And the positive side of the DC barrel jack does go directly into the voltage regulator there. And yeah, it's 5-volt output right there, and it goes to one of the ICs. So yep, okay. Well, there we go. That is DC. So I'm gonna have to use my bench power supply at the moment. So I'm just gonna check that the bench power supply here is set for center negative. And it is, we're at 7.1 whatever volts. That's good enough. You don't need more than that. In fact, it'll just make this thing run a lot cooler. Check out the little tiny heatsink that's on there, very small. This is running, it's on right now, and we're getting 4.919 volts into one of the chips. And yes, without a doubt, when you turn off the power switch, the voltage regulator is still in circuit. It's drawing 6 milliamps right now. Looking at the scope, we're gonna look to see what the video output of the PPU looks like. Oh wow, nothing. On the PPU, I'm pretty sure pin 18 is the clock. Don't have a clock. So we're not gonna have any kind of video signal. It's just stuck high. So on the crystal oscillator, we should be seeing that 21 megahertz, and I am not. Well, I think the Famicom requires a bit more in-depth troubleshooting because without a clock signal, we're not going to get any kind of functionality out of this device. And I'm not sure if that PPU is actually going to work with that hole I just drilled in it. So I'm going to leave the full repair and the AV modding of the original Famicom to a part 2 video. But I have to admit, I've got further in this video than I thought I would. Actually looking at all 4 machines, and we had a little bit of everything. Some excitement with exploding components, and we had an actual fault on one of these machines that kept it from working properly. So I hope this video was interesting to anyone who's working on repairing these Famicoms. These machines really are pretty reliable, especially the front loaders. Really, it's just those cartridge connectors. So a little deoxit and moving them around usually brings them back to life. And as far as longevity of using deoxit on these, I have some Nintendos that I deoxited years ago, and they still work flawlessly. Cartridge in every time, just works perfectly. So if you enjoyed me fooling around with some old Nintendos, then I would appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters. Names go up beside the screen. They make it possible to do this full time. Subscribe, like, you know, the usual YouTube stuff. And I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.